Hello everyone. Okay, so I think all of you are from either electrical or electronics background, and both are fine, or BTech, MTech, both are fine. So first, I will cover many points, but let me just start. What is just a second? So I will come to what is a VLSI from a different angle. So let me start. Let us suppose if you will see in your surroundings, if you will see in your surroundings, you might see some mechanical gadgets. Okay, some mechanical gadgets. Like let us suppose if you have uh, a mall or some shopping complex, at the entry point, you might see there is some security guard, and that might holding a counter might holding a counter, and let's suppose some years back that was a mechanical counter, even still you can see somewhere. Okay, so if it is a mechanical counter, so what he needs to do, he just need to press the button to count the person. Let's suppose if he pressed for the 100 times, then that means a number of customer entered is 100. So, if you want to just fabricate it, or if you want to construct it, it will become very easy, because what you are doing, you might just have a just a needle, okay, mechanically. So that is very easy. Easy means relatively easy, because every gadget is construction is tough, but relatively it is easy. You can even have at your own counter. Okay, you can have some way, like you can hold some sticks, and you can count with respect to that as well. But when I ask to you to, can you tell me the record for last 10 days with this counter? So answer is, you will not able to tell me from last 10 days what was the count, or how it was, like it was decreasing, increasing, constant. How was the count? So you will not able to tell. Or let's suppose, if you will see, ultimately, what is my goal and what I want to conclude here, a mechanical gadget have um, less less feature less feature, but but easy. Okay, easy to construct or easy to make, something like that. Okay, तो मैकेनिकली आप देख पाते हैं कि आपके पास जो लेटर सपोज सम रिपेयरिंग है या कुछ भी है, तो मैकेनिकल में बहुत सी चीजों में रिपेयरिंग हो जाती है, बट इलेक्ट्रॉनिक्स में नहीं हो पाती है. So let me just talk about how we can overcome this. If we will move towards a electronic gadget, let's suppose e-counter. E-counter means something electronic gadget. So what happens now? What you need to do, you should have a circuit. You should have an electronic circuit for that. And in that, if you will give a input, let's suppose by pressing a button or something, so you should be able to give the exact counters. Let's suppose if you press for the 100 times, you should be able to give this value as 100. And it should have some memory element as well, like flip flop. So flip flops are memory element, and after, let's suppose 10 days, if you will come, so you will be able to see the record as well based upon its capacity. So now we will having more features. But now what is the difference in these two? Even the village itself, you can make, or you can just construct this counter. आप गांव में भी देख सकते हैं कि एक छोटा बच्चा भी इसे किसी ना किसी तरह से इस काउंटर को बना सकता है. बट आई थिंक इट इज ऑलमोस्ट इम्पॉसिबल. इस गैजेट को कभी भी कोई बना ही नहीं सकता है. इस गैजेट को कभी भी कोई बना नहीं सकता है, जस्ट बाई having initial knowledge or something like that. Okay, so now how to proceed with this? So if you want to proceed with this, then what you will do, you will just have a circuit finally, because every electronic circuit at least have some circuit. Let us suppose something like that. Let us suppose something like this. If we are having this circuit, okay, So if we are having this circuit, now what this circuit is doing, based upon some input, we are getting some outputs. Now, now, if you are thinking like you will make this circuit as a gadget, as a gadget. So what you need to do, you just need to fabricate it, and the circuit you need to present in the form of integrated circuit, that means IC. So in the form of IC, you need to present it, or what IC will do, for some specified inputs, it should have some specified outputs. That is nothing but based upon its functionality. Now, just let me just talk about if it comes into the electronics. So here we have one challenge, that is it's a size. It's a size. Okay. So if you have electronic gadget and now you want high performance and lesser size, so what you need to do, these gates you need to you need to put such that size should be as smaller as possible. It should be very less. Size should be very less. Now, based upon the size, we have multiple technology, and among that only we have one technology, that is very large. Okay, so very large scaling IC. So that means इसमें क्या है, बहुत ही लार्ज स्केलिंग करी गई है, मतलब एक फिक्स अमाउंट ऑफ पर यूनिट एरिया में बहुत ही नंबर ऑफ गेट्स बहुत ही ज्यादा रखे गए. So that means VLSI. So it's just not a technology. Now, what we discussed, what is a VLSI? It is just simply technology. Now let me just talk about challenges. So if you are thinking, as I explained about the mechanical gadget, everyone can make it simply. Okay, so even you can make it at your home like a toy. ठीक है, आपने देखा भी होगा, बहुत से लोग बना लेते हैं, कुछ भी बना सकते हैं स्टिक का यूज करके, कुछ भी. बट दिस इज नॉट पॉसिबल. लेट मी टॉक अबाउट हाउ इट इज पॉसिबल from the naturally available things to a gadget. How would be the way? So if you know, this is the IC which is having circuit in this. Now what is this? Are you thinking this is a circuit? No, this is a symbol. ये तो सिंबल है. क्या ये नेचुरली मिलते हैं सिंबल? आंसर इज नो. हमारे पास नेचुरली क्या अवेलेबल है? We have metals, we have air, we have some plastic, okay, which is a kind of, so we have such materials only. We have sand, okay, so we do not have such symbols. How can we make it? So let me go one step back. These symbols, that means every gate is made up of with some MOSFETs like this. Now, now you might say, still what it is? सर क्या ये बाजार में मिलता है? सॉरी, ये नेचुरली मिलता है? आंसर इज नो. दिस इज आल्सो सिंबल. दिस इज आल्सो सिंबल. सो हाउ यू विल मेक? अगर आप अपना गैजेट बनाना चाहते हो, लेट्स टॉक अबाउट द चैलेंजेस. सो दिस इज आल्सो सिंबल. So now what you will do for this symbol, I think we have a fabrication process. I think आपने पढ़ा भी होगा IC fabrication में. So MOSFET construction, like it should have a P tub, N tub, and then it should have some channel length specified. Then based upon the electron or holes, it should have N MOS and then P MOS. So now whatever you will use here, that everything should available from the nature only. Okay, and for this I think you have some fabrications method as well. So like that, you have different challenges. तो इसको कोई क्यों नहीं बना सकता? कोई टॉय या कोई बच्चा क्यों नहीं बना सकता गांव में कहीं भी? बिकॉज दीज फैब्रिकेशन मेथड्स आर वेरी वेरी डिफिकल्ट. ये इतना डिफिकल्ट है, वेन एवर यू आर हैविंग ए फैब्रिकेशन, अगर इसके लेट्स सपोज सम एक्स यूनिट और एक्स मीटर डिस्टेंस पर अगर कोई लेट्स सपोज सम ट्रक इज गोइंग ऑन, ठीक है, तो उसके वाइब्रेशन इतना carefully this fabrication should happen. Okay, so now let me just talk about finally we know what should happen. So we know from the naturally available things, we will go till IC. So this would be our final process. So from here to here. So let me just talk about this part is common to all from MOSFET to circuit, and then circuit will change for each and every devices, and then we will make a IC. So let me talk about what happens here. So if you will see, let us suppose you have a circuit, for example, counter, or for example, adder, or for example, calculator. Let's suppose this is a full adder. Okay, I think everybody know about the circuit for full adder or half adder, whatever it is. Okay, so now what you are doing, you just thought to make a device, and you have this as a half adder. And now what you thought, you just thought to fabricate it, and you made a IC. And now this is the gadget which is available in the market named as adder. जैसे आपको कैलकुलेटर मिलता है, या कैलकुलेटर की एक आईसी या प्रोसेसर जो भी बोलेंगे उसको मिलता है, लेट्स सपोज एडर का अवेलेबल है. Now what happens in this case, you just constructed, but you just constructed, but what you observed, what you saw, whenever you make this gadget, if you are giving 5 and 4, you are getting here, let's suppose, some 8. So what mean by this? The fabricated IC is not working expected. जैसा हमने सोचा था ये एडर की तरह काम करेगा, वैसा ये काम नहीं कर रही है. Just because of what? Just because you directly fabricated it. You just have a circuit diagram and you just fabricated it. और आपने ऐसे कहीं एग्जांपल्स भी देखे होंगे, समटाइम्स लाइक इंटेल समटाइम्स सम ईयर बैक एक फॉल्ट आया भी था, प्रोसेसर में फॉल्ट आया था. समटाइम्स आप देखेंगे कि कभी प्रोसेसर्स में भी फॉल्ट आ जाते हैं, ठीक है, तो वो अपना वापस लेते हैं या उसको कुछ अपडेशन देते हैं, क्या करते हैं, लीव अबाउट दैट, बट समटाइम्स दे माइट हैव फॉल्ट एज वेल. ओके, सो इट इज लाइक दैट. So now what happens here? So it might fail due to two reasons. One is fabrication fault. कोई डस्ट पार्टिकल आ गया, कोई ट्रक निकल के चला गया, वाइब्रेशंस आ गए, पावर सप्लाई में फ्लक्चुएशंस हो गया. Okay, there might be any reasons. So this is second, and first one is functional fault, या functional bug or fabrication bug. So fabrication bug can be reduced to almost zero, but 100% जीरो नहीं कर सकते उसको, हम ऑलमोस्ट रिड्यूस ही कर सकते हैं, और उसका हम कुछ कर भी नहीं सकते, ये हमेशा रहेंगे. But what we can do on the functional bug, yes, definitely we can do. What we can do here, what we can do between these two, what we have to do here, we have to just do the testing. So what we missed here verification. Now verification means इस सर्किट को आईसी की गैजेट की फॉर्म में बनाने से पहले हमको इसको फंक्शनली जांचना चाहिए था, क्या ये एज एक्सपेक्टेड वर्क कर रहा है या नहीं. दैट वाज आवर गैप, एंड ड्यू टू विच व्हाट हैपेंस, यहां पर अगर हमारा आईसी फेल हो गया तो हमारा टाइम एंड मनी, धन व समय दोनों हमारा व्यर्थ हो गया. एंड कैन यू इमेजिन who the engineers who are working at the fabrication, they are working on the package of 2 CR, 3 CR, okay, 10 CR itself. तो कितना अमाउंट और कितना समय हमारा वेस्ट होगा. So to avoid that, what we have to do, we just need to do verification before fabricating it. Now, so if I am talking about verification for this circuit, so you can do manually. You will check for all possible values here, 0 0 0 1 0 2 dot 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 99, and you will check all possible values, and then you can say yes, circuit is fine, and then you can fabricate. But can you imagine a Intel i21 processor जो अभी आया नहीं है, जो 2 साल बाद आएगा, can you imagine, can you verify that manually? Answer is no. So how to do a verification for such such circuit? Adder तो adder you know, so using your brain you can verify. but yeah, अगर मैं calculations की ही बात करूं, let's suppose you have x square circuit, you have x power 4 circuit, you have x to the power 1000 circuit, or you have x to the power 999 power circuit. How you will verify? So जब human का brain का limit आ जाता है, तब computer start होता है. So here also we will do the same thing. We will do some verification through computer. Let's say through processor, or let's say through some CPU. You understood? Now if you are moving towards computer or processor, so what happens for this verification if you are using CPU or some processor? So what happens if you will just see the left hand side and right hand side? 1 minute. So if you will see here, this is your circuit which is to verify, and this is your CPU or computer or CPU. Now try to understand what happens. What is this? So for you it is a circuit, but computer के लिए तो एक print में करी गई drawing है ना. It's just a drawing. Print नहीं, paint में करी गई simply drawing है. So this is paint for the computer. So there is a big gap. You know the circuit, but computer do not know this circuit. What computers know? Computers only know the 1 and 0. Actually computer understand program, and program are set of instruction, and set of instruction are written in the form of some alphabets, and alphabets have a ASCII value finally 1 or 0. तो एक साइड में ड्राइंग है, एक साइड में 1 0 है. How will you do the mapping? So there is a big gap. So then one new thing introduced here, and that is nothing but so to overcome or to fill out this gap, one new thing introduced here, and what is that? So that is nothing but HDL. What is this HDL? This is nothing but हार्डवेयर डिस्क्रिप्शन लैंग्वेज. मतलब जो हमारे पास एक्चुअल में हार्डवेयर था उसको डिस्क्राइब कर दो इन द फॉर्म ऑफ लैंग्वेज जो कंप्यूटर को चाहिए या जिसे कंप्यूटर एटलीस्ट समझ पाए. दैट मींस हार्डवेयर describe language. So we have to describe this hardware in the form of language. So for example, let's suppose you have a NOT gate. So for that we should have NOT. Now NOT can be understood by this computer in the form of 1 or 0 ASCII value. So understood how this HDL fill up the gap. So from here HDL comes into picture. That's why in this VLSI you should know how to design circuit. That means you should understand the digital, and after that it will become very important to understand HDL, that means hardware description language, and it contains some Verilog or VHDL, and the enhancement language as a system Verilog. Okay, so using this what happens? अब क्या होगा? Now how flow changed? Now you have your circuit from the MOSFET. सबसे पहले तो हमारे पास नेचुरली चीजें जो अवेलेबल है उससे MOSFET बनाया, MOSFET से सर्किट बनाया, सर्किट को डिस्क्राइब कर दिया लैंग्वेज की फॉर्म में, लैंग्वेज से कंप्यूटर को समझाया, कंप्यूटर ने हमें बताया यस वेरीफाइड, and now you designed or now you fabricated the IC. You understood? I think everybody understood. Now after verification actually and before fabrication, so some analysis also we need to do. Okay, so that was just for functional verification, and after that we might need to validate some performance analysis as well. Performance or let's suppose chip size. जैसे हमने फंक्शनली तो करेक्ट कर लिया, बट उसके साइज को चेक करना, क्या और छोटा कर सकते हैं साइज को, दैट मींस जो गेट है उनका प्लेसमेंट कैसे करना है, उनको प्लेस कैसे करना है, ओके, उनको हमें यू किस किस जगह पर हमको प्लेस करना है, राउटिंग या फ्लोर प्लानिंग, जो एक्चुअली इसको बोलते हैं फ्लोर प्लानिंग, हमें किस तरह से करनी है, या परफॉर्मेंस एनालिसिस, दैट मींस जो प्रोसेसर हमने बनाया था वो टाइम में परफॉर्मेंस सही दे रहा है ना, मतलब परफॉर्मेंस मतलब 1 सेकंड में कितने काम कर रहा है, दैट इज द परफॉर्मेंस। अगर 1 सेकंड में 10 काम कर रहा है, 1 सेकंड में 20 काम कर रहा है, 20 वाला ज्यादा हाई परफॉर्मेंस का है, राइट? सो दैट एनालिसिस आल्सो वी हैव टू डू, and some physical things, okay? So here I can split this entire process into two parts, and this part is known as front end and this part is known as back end. And if you will see, so here based upon the dividation you have different jobs as well, क्योंकि ऐसा नहीं है एक ही बंदा सारा काम कर सकता है, either you will be working, either you will be, मतलब काम कर तो सकता है बट एक्सपर्टीज एक ही एरिया में होती है, ओके, ये एक्सपीरियंस, either you will be work as a digital design engineer here, either you will be work as a verification engineer, or either you will work as a DFT or STA, or you will work as a physical design engineer, or you might work in the fabrication, so now this is all what is a VLSI and where is the actual requirement and where you can go. So now let me just talk about why we have so much of demand, मतलब इतनी डिमांड क्यों है, why VLSI? So why VLSI is in demands? Yeah, how we are getting so much of package like 20 LPA, 40 LPA, 60 LPA, 1 CR, 2.5 CR? Why we are getting so much of LPAs? Okay, so why it is in so demand? और क्या आने वाले टाइम में भी ऐसा रहेगा या नहीं? Let me talk about just on that. So let me just talk about, or let me just say, VLSI की जो requirement है, that is completely unique, or as a VLSI engineer, why? If you will find out someone, so there are two domain, hardware and software. So अगर आप किसी से पूछोगे in which you are expert, so most of the guy or almost 80% of the guy will say I am good in hardware but not in software, I am good in software but not in hardware. Almost 80% of the candidate will say like this, but only 20% of the candidate will say yes, I am perfect, not okay की बात नहीं चल रही है, perfect, I am perfect in the hardware and I am perfect in the software, and that is the requirement of a VLSI engineer. Why? Because if you'll see here, the HDL, so you tell me what is actually HDL is doing. Just see the left hand side and just see the right hand side. If you will see the HDL, so if you will see the HDL, then HDL is the first hand is you should know the circuit completely. क्यों? क्योंकि तभी आप प्रोग्राम लिख पाओगे जब आप सर्किट पता है. Can you imagine a guy which is from computer science and he do not know about flip flop? उसे ब्लूटूथ मॉड्यूल की प्रोटोकॉल नहीं पता तो उसके लिए प्रोग्राम क्या लिखेगा? And can you imagine a guy who know the complete protocols but even who do not know the syntax of for loop? उसे प्रोटोकॉल पता है, उसे सर्किट पता है, पूरा हार्डवेयर में एक्सपर्ट है, बट उसे फॉर लूप नहीं पता कैसे लिखते हैं, प्रिंट नहीं करा सकता हेलो वर्ल्ड. कैन यू इमेजिन दैट गाय? सो बोथ might be expert in their each domain, but they will not be eligible for this case. Who will be eligible? Only a guy who is expert in hardware as well as software. That means he should completely know about the circuit designings and he should be expert in writing the programs, because this circuit itself we need to write in the form of program. यही तो है, हार्डवेयर को डिस्क्राइब करना है लैंग्वेज में. So you should know hardware and you should know L, that means language. So HDL, you should be expert in the hardware, you should be expert in the language. तो ऐसे कैंडिडेट हमेशा कम मिलते आए हैं, हमेशा कम मिल रहे हैं, हमेशा कम मिलते रहेंगे. That is the uniqueness. And let me talk about the job skill. So if this is the entire project and let's suppose if it is taking 100 days, वैसे तो ये 3 साल 2 से 3 साल लेता है, but let's suppose if it is 100 days, so out of this 100 days up to here it will require 70 days, and after this it will require 30 days. That means most of the time is spent in the verification itself, in the verification. So that's why in the market this, क्योंकि यहाँ पे काम ज्यादा होता है, that's why अपॉर्चुनिटी या रिक्वायरमेंट ज्यादा है. डोंट थिंक कि इसी फील्ड में रिक्वायरमेंट ज्यादा है बाकी फ्लॉप हो जाएंगे. देखिए अगर एक चिप बन रही है, उसका डिजाइन भी पक्का होगा, वेरिफिकेशन भी पक्का होगा, एसटीए भी पक्का होगा और फैब्रिकेशन भी पक्का होगा. ऐसा तो नहीं चिप को बीच में छोड़ देंगे. सो स्कोप इज सेम, बट रिक्वायरमेंट की बात कर रही है, मतलब उस काम को करने के लिए ज्यादा लोग चाहिए. ये है बात. काम तो होगा. अंडरस्टूड. So it is like just like a scale. So I think I covered everything, but let me just talk about some misconception or something about that VLSI or who are eligible. So let me try to answer such questions. Okay, so if you'll see here what we are planning, so we are planning correcting students of the semiconductor correcting students to the semiconductor industry. So what mean by this? Actually what happens if you are from BTech, so in the BTech uh, in in most of the university they do not have VLSI as a subject or project. तो देयर इज अ गैप. जो इंडस्ट्री को चाहिए वो उनके एक्चुअली सिलेबसेस में है ही नहीं. अभी कुछ यूनिवर्सिटी ऐड ऑन कर रहे हैं बट अभी तक नहीं था. सो हाउ यू कैन अचीव द रिक्वायरमेंट्स? सो जस्ट बाय joining us, or if you will cover all the things like how to writing the languages by describing that hardware in the formal language. That means by doing the HDLs, by knowing Verilogs, by doing system Verilog, and after that some protocols as well, by knowing the UVMs. Okay, so by knowing such things you will be able to join that industries. Okay, so what is a VLSI? I think I already covered. If you might have some doubts, you can ask in these areas. I already covered. This is simply just technology. Okay, so which refers to how we are largely doing scaling. Okay, बस वही है. VLSI एक टेक्नोलॉजी है, बट उसमें एक्चुअली क्या हो रहा है वो हमने बताया. नाउ लेट्स टॉक अबाउट एप्लीकेशन. जहां जहां भी आपको लगता है ऑटोमेट चीजें हो रही हैं, दैट मीन्स समथिंग ए प्रोसेसर, बिहाइंड दैट देयर इज ए प्रोसेसर, और उस प्रोसेसर में ही है आईसी, और वो आईसी ही है दैट इज नथिंग बट चिप, और वही बना है VLSI से. दैट मीन्स यू कैन सी इन द CPU, इन दिस electronic gadgets, in the camera, and everywhere you can see so everywhere you can see it is used. Now evolution of VLSI. So evolution, I think there is nothing in this, just we need to see how it comes. So it is starting from the SSI, that means small scale. पहले small था, फिर वो medium हुआ, फिर वो large हुआ, फिर वो बहुत ज्यादा large हुआ. तो अभी रिक्वायरमेंट बढ़ती जा रही है, क्योंकि एक चीज ऐसी है जो साइज इलेक्ट्रॉनिक गैजेट का सबको छोटा चाहिए और परफॉर्मेंस सबको हाई चाहिए. So just for that purpose VLSI got evaluated. Now VLSI ecosystem. So how it is ecosystem? So there are some chip design companies and chip makers. Okay, so they have coordination between them, and we have some foundries as well for fabrications. जैसे कि best example is TSMC या Samsung है, तो ये फैब्रिकेशन का काम करते हैं. मेनली TSMC ने मार्केट पकड़ा हुआ है, सो मेनली दे आर डूइंग फैब्रिकेशंस. और उससे पहले क्या होना चाहिए, मैन्युफैक्चरिंग या फाउंड्री से पहले क्या होना चाहिए, हमारे पास चिप डिजाइन होना चाहिए, चिप मेकर होना चाहिए. तो इसमें जैसे इंटेल है, ये अपने प्रोसेसर बनाते हैं, और माइक्रोन है, एंड AMD है, ये अभी अपने प्रोसेसर बना रहे हैं. ओके, और कुछ नए कंपनीज भी आ रहे हैं, right? So this is ecosystem, how it works. Now trends in the VLSI industry. So trends is definitely yes, as I mentioned, जहां कहीं भी आपको ऑटोमेशन मिलेगा, तो ऑटोमेशन के लिए कुछ ना कुछ एक चिप और प्रोसेसर चाहिए, एंड दैट विल बी बेस्ड अपॉन ओनली ए चिप और ए प्रोसेसर. सो दैट इज पॉसिबल ओनली जस्ट बिकॉज ऑफ दिस VLSI. क्योंकि हमें हमेशा चिप चाहिए होगा और उसमें VLSI टेक्नोलॉजी से ही पॉसिबल है. ओके, and if you will see even the government also focusing, like we have program Semicon India. Okay, if you'll see in details, and the global globally the leading company are Micron or something. Okay, so they are doing very well. They are doing very well. Okay, so I think you do not have any questions. If you
Just
have, you
wait,
can
wait,
ask.
wait,
Okay,
wait.
I will come to.
Yeah,
Yes.
just wait, wait, wait. So everyone just rejoin the same link if meeting get ended in 1 minute. So anyone have till now any doubt? Anyone have any doubt till now? Anyone any doubt till now?
Yeah, no doubts, but just a background. Students here are from first year, second year, and third year. So please help us them understand at their
Yeah,
level,
yeah.
right?
We will come to that also in the end. Just let us finish this PPT. It will be covered in 10-15 minutes. So yeah, just
Sure, sure.
yeah, continue. Okay. So everyone just rejoin the same link. Everyone just rejoin the same link. Yeah.
So yes. So importance of VLSI. इंपॉर्टेंस ऑफ VLSI, एज आई ऑलरेडी मेंशन, एक डिमांड है जो हमेशा परफॉर्मेंस हाई चाहिए और साइज और पावर कंजम्पशन सबसे कम चाहिए. जितना छोटा साइज होगा, lesser size will require lesser power consumption, and we require a high performance. So that everything can achieved only with the help of this VLSI technology. As you know, I mentioned SSI, after that we got MSI, then LSI, then VLSI. तो वाई? बिकॉज ये रिक्वायरमेंट हमेशा रही है, हमेशा रहेगी. साइज सबको कम चाहिए, पावर कंजम्पशन कम चाहिए, बैटरी ज्यादा चले, और परफॉर्मेंस हाई चाहिए, काम जल्दी हो. ओके, सो दिस इज द VLSI डिजाइन फ्लो. Whatever I explain, it is almost same with having valid step, because each step is having a category. जैसे कि chip specification, first you need to give the specifications. What may specification? Let me take an example of half adder. तो half adder में भी specification होगा, कितने bit wide है, क्या maximum limit है, क्या रीसेट है, क्या सेट है. तो दीज आर स्पेसिफिकेशंस. बट इफ इट इज ए मेमोरी, क्या उसका एड्रेस है, क्या डेटा विड्थ है, दीज आर स्पेसिफिकेशंस. Now after specifications, you should be able to design. That means you should be able to design and functionally verify. Okay, so these are the steps which are coming in the front end. Don't be focusing on the name, just understood overall. Okay, as I mentioned here, so it is so that is equivalent to this, whatever I explained here. Okay, these are having a genuine names. Okay, so like DFT testing and verification and the chip specification, such that. Okay, but overall it is nothing but whatever I explained in this diagram. Now we are having floor planning and placement stage, and then clock synthesis, then routing, and then final verification, then GDSI. So what is this? This is back end part. Floor planning. What is the floor planning? I mentioned कि let us suppose आपने ये तय किया कि I will be placing 10,000 gate in the specified area. So now if you are doing smartly floor planning, then उन्हीं गेट को आप कम साइज में फिक्स कर सकते हैं. But if you are not doing smartly, the same gate might require more space. So that's why floor planning is also important factor. Okay, to reduce the chip size. So this everything come in the physical design. That means back end part. That means in the back end part. Now we'll say design flow. So it is almost same thing whatever I discuss here. So this is also a design flow, just with the help of this flow chart, nothing else. Okay, here also floor planning and power planning and placement, these everything come in the back end or physical design, we also say. Now let me talk about VLSI job profiles. So I explained here, in this entire flow you might stay anywhere, wherever you have your interest. But yes, if we are talking about the jobs, so jobs is not nothing but a responsibility and in a expertise area. So someone can work either in the designing or in the verification or in the ST or in the DFT or in the this fabrication or in the physical design. So based upon that we have multiple so we have multiple profiles. So just see here. So we have RTL design engineer. That means who have interest in the designing. So they might go to the profile of RTL design engineers. So they have to design actually. They have to design actually the chip based upon the specifications. Now FPGA designers. So FPGA or RTL designer is almost same. That means in that case you have to design RTL, or in FPGA you need to specifically work on the FPGA, but both are similar. For your level you might understand both are same. That means one is a design profile, you can understand like that, and one is a verification profile. So this is nothing but how I split it. If you remember, I made some circuit here, so that is a designing, and where I mentioned HDL, so that is nothing but verification. And somehow you need to work on in between. So you also have design verification engineer profile. So these are the front end profiles, and in the back end you have multiple profiles like post silicon validations and this DFT or static timing analysis. I mentioned like you have to do timing analysis as well. Okay, and then synthesis and physical design engineers. So you should not go in detail, but you just understand the category, how they are divided. So based upon this diagram, you should have everything clear. I think you should have everything clear based upon this flow. So now if you will go further, so other VLSI profiles as well, that is related to analog and fabrication. As I mentioned, like fabrications में भी कुछ हमारे profiles और analog में भी. So IC designings में radio frequency में इसमें Qualcomm बहुत अच्छा काम कर रही है, right? और हमारे ये भी काम कर रहे हैं. Micron वगैरह बहुत अच्छा काम कर रहे हैं. Then AMS design verification, that means analog and mixed signal design verification engineer or analog customer. So these are custom profiles actually, but core profile are these only. Okay, front end and back end. Now this is fabrication related. तो फैब्रिकेशन में भी एक अपने आप में फील्ड है, उसमें भी बहुत सारे प्रोफाइल्स हैं, जैसे ईच है और डिपोजिशन इंजीनियर है, एंड लाइक दैट फेलियर एनालिसिस. जैसे उसके बाद भी हमारा फेलियर हो गया या क्वालिटी एश्योरेंस है कि हमें जो अचीव किया, जो हमारा टारगेट था, दैट वी रियली अचीव्ड और नॉट. ओके, तो प्रोसेस इंजीनियर. सो दीज आर नथिंग बट in the field of fabrication. So you should not go in depth of these profiles. You just keep in mind there are 4 type of category. One is front, and second one is back end, and then analog, and then fabrication. Okay, because if you will work in this, you might work in the second one. Okay, but switching from front end to back end is tough relatively. Switching from design to verification of design is relatively easy. So that's why I'm saying you should keep in mind there are 4. Now we have some misconceptions of VLSI domain as well. Salary is low. AI ML will kill the job. अरे सर, AI और ML तो आएगा ही VLSI की वजह से, उसमें प्रोसेसर तो लगेगा. So it is not like that. Salary is low. Why it is low? Okay, if somebody is working at low salary in this, what is happening? बीच में जो मीडिएटर है वो आपके पास कम अमाउंट पहुंचा रहा है. That might be the case, but market wise it is not like that. Salary is low, so every product based company is giving a good package of 30, 40, 60 LPA, and even in the CR as well. Recession is permanent? No, recession is happen in every field based upon the projects or based upon the flow. So it is kind of periodic. It cannot be permanent in any sector. It is periodic, like slow, fast, slow, fast, or low, high, low, high. It is like that. And what is the good point of recession? रिसेशन का गुड पॉइंट क्या है? जब भी रिसेशन आएगा उसके बाद भरपूर मात्रा में वैकेंसी आएगी और भरपूर मात्रा में मार्केट अप आएगा. सो बिकॉज इट्स ए पीरियोडिक. अगर एक बार लो गया है, अगली बार पक्का हाई आएगा. सो दैट्स इवन पॉजिटिव पॉइंट. ओके, so working in the VLSI industry is boring and repetitive? Answer is no. Every time you are seeing new projects or something like that. Okay, so every time you are seeing, it is not like that. Okay, so few more conceptions are: MTech is compulsory. Answer is no. Even BE or BTechs are eligible with, if you know the Verilog, if you know the system Verilog, if you know the UBM. That means VLSI for all or some coaching institutes such as we are providing the courses. So this is the gateway to get entry in the industry. Okay, and average colleges are not eligible. So it is not like that. But if you are from the good college, reputed college, then definitely you will get the priority. But it is not like that. It is a rule only IITs or only NITs are eligible. Only EC students are eligible. Answer is no. Electricals are also eligible. And if you are expert, if you have the relevant branch somehow, then also you will are eligible. Okay. So roadmap to start career in VLSI. So yes, so these are the way what you can do. You can just have basics of Verilog. Then after that, through VLSI for all YouTube and app, you can have some free courses. But definitely through free courses, you will learn many things. But if you will do the advanced course as well, like protocols or something, then definitely there the chances for having entry in the industry will definitely increase, and almost surety, you have the surety. Okay. And then you can have idea about some alumni and referral as well, so you will get some referrals as well, through which you will get the job. Okay. Now, which profile to choose? So this is actually based upon the interest, so it's an individual choice. But still let's see. If you are code lover, that means if you have interest in the code or fixing bug, you might go in the front end. But back end में ज्यादा coding वगैरह कुछ है नहीं, just आपको tool पे काम करना होता है, and so you might go to the back end. Okay. So now technical skills interviewer looks. So basically you should know the digital, and if you are talking about the front end, so front end you should know the UVM and this Verilog and some more languages, which is system Verilog. Okay. But if you are in the back end, so you should know the floor planning, you should know the routing, you should know the placement, and you should know the physical designing things. These things you should know. Sometimes you should know the tools as well, how to run them, and definitely some communication and problem skill you should require, which is mandatory. Okay. So who can up to this career? I think every individual which is from BTech, EC, electrical engineering, okay, or MTech, ME, they all are eligible. They all are eligible. Okay. And sometimes if somebody is not specifically from electronics and some from relevant, but he or she is having good knowledge, they can also opt. Okay. So there is no barrier for them. And how we can help to you? I think we already mentioned. We have free courses for the beginners. We have subject wise free test series and the counselings. Plus we have 100% job assistance as well. And mentoring the labs, and how to do the projects. And there is we always try to build up a bridge between some campus to industry as well, so you can easily go towards your industry. Okay. So like that we will proceed. And if you'll find out some platform, so there might countless things like one-to-one coaching is available, and doubt solving sessions, and 24/7 mentorship is happening, and then quiz happening, team quiz are happening, and mock interviews are scheduling, and some study material and notes are available. So there are countless things which we are providing from our apps. And there are some place student as well. You can see multiples which are countless, but here we are just having few things. Okay. So if you have some doubts, so now you can ask. So if any question.
Yeah, thanks for such a wonderful talk about VLSI. Just one thing, juniors, if you have any questions, please ask. If you have any project related questions, like what projects you should make being fresher in the industry, so please ask. Yeah, I guess I'll
Okay.
ask on behalf of them.
Yeah.
Hello.
Yeah, you can continue. I will ask one by one.
Sure.
Yeah.
Yeah, I was asking on behalf of them that many students were asking me that were the best projects that we can do to prove our candidature in interview. So can you please advise on that? These students are from second year and they are currently doing their digital and analog electronics in their semesters.
Ankit, you can continue. Ankit, you will answer, or I should answer?
Okay. So about the projects. So the question is especially about the projects.
Yes.
And they are currently doing digital and analog electronics right now.
Yes.
How can they
Yes.
proceed?
So as I mentioned in this flow, definitely if you are looking or if somebody is looking for the front end, so in the front end, when we will say you are ready for the placement, until and unless you are able to design, as well as you should be able to verify. And whenever I'm talking about verification and design, so you should be able to design at least 2 or 3 projects. For example, the beginners are, it could be some memory, that means it could be for RAM, it could be for routing, that means router, or it could be some extra with some protocols, we can say with some protocols like Bluetooth module or AMBA protocol, such that, or I2C such protocols one. So you should be able to design, that means you should be able to design in the Verilog, that means in the HDL, that RAM, and after that the same code you should be able to verify in different methodology in the system Verilog or in the UVM. And once you will do the verification, we will count this as you are expert in the one project. So such that we will minimum count is 3, and based upon the requirement it might go beyond that as well. So
Bas-
basically, whenever a candidate is able to design as well as is able to verify the same design through system Verilog, and we will be working on EDA tools. We will be working on live EDA tools. So on those EDA tools, if a candidate will be able to design as well as verify, and then final status is uh, if he will be able to done, then we might say yes, candidate is ready. So we'll do at least 3 projects on the EDA. Like that we'll proceed after learning all the modules.
So yeah, these are for digital, right? So for digital, we are covering basically 3 mini projects. Like you can do the basic FSM based, that is for like voting machine or traffic light controller, digital clock, like that. Second year or first year student you can do. But if you are going for the major project, which is most important, like protocol based projects with a verification, like UART, I2C, FIFO, asynchronous FIFO, synchronous FIFO is there, AMBA protocols, that is very important. Then yeah, these are the projects that you can cover. Third and fourth year student can do the protocol based project. But if you are a first year or second year, then mini project of FSM based, like mini project like voting machine, traffic light controller, and digital clock. These are sufficient.
Okay. Thanks for the inputs. Just for the sake of clarity, guys, protocols are basically communication protocols between two modules in a chip. For example, you see two squares here in the screen being shared. So if you want to share one data from one square to other square, you use a communication protocol, and these UART, SPI are protocols for that. So yeah, you can do these projects. And as far as I can understand, so students can do digital electronics, analog electronics, then go on to Verilog and do a project then on Verilog. Am I
Yeah.
right? If I
Basically, they should do one thing. They should first of all download the application. There are
Sure.
6 free courses. There are 6 free courses. They should, both the free courses, like 50-hour free courses are there. Depending on the interest of basis of the free courses, they should choose their field first. Choose their field. What is the best field for them? Fine. So it is not like that they are learning analog as well as the digital, right? Obviously, they have to
Yeah.
go put your more efforts for one profile, right? So that is a thing. So
Okay. Yeah, I guess Abhishek has a
yeah,
question.
Abhishek, ask your question.
Good evening, sir.
Good evening.
Sir, actually, we had done some projects on Arduino boards and ESP boards, and sir, we have a little knowledge about protocols like UART and SPI I2C. But sir, how to shift from IoT to Verilog, or means doing a project in a mixture of embedded plus VLSI?
The things you are doing, Arduino and all, those are actually microcontroller, and you are doing basically embedded part, right? And VLSI is obviously, if you are learning both the things, obviously it will be hard. Just focus on either embedded or VLSI, right? That will be good. Protocol is common in both, but obviously the language you are using in Arduino is different, and in VLSI it is completely different. So obviously you can't do both the things parallelly. Just focus on one thing, or you can learn both the things. Start with basics of both, right? Whatever you are fascinated by one of them, you can go for that. Fine. You can learn both also. But both are completely independent. It is not like it. Only few parts are like common, like protocol you said. Only theoretical knowledge is common, na? Basically, in Arduino we are not using Verilog, right? So both are independent, but some things are common also.
Yeah, so knowledge of Verilog is very important here, and mastering it through practicing. I know a website called HDL Bits. I guess you can practice
Hmm.
Verilog from there, and then
Yeah,
yeah, implement those projects, UART and SPA.
yeah. Because by learning IoT, you can't get the job in VLSI, or by learning embedded, you can't expect the job in VLSI. By learning VLSI, you can't expect a job in embedded. Some part is common, but you have to learn like independently. It is not a substitution, right?
Yeah, yeah.
Uh, Anyone
Uh,
else? Any query? Okay, I will tell the name. I will go name by name. We know any query? Uh, Vishek Kumar, Arun Kumar, Viswas, Vamshika, Darshan, Govind Kumar, uh, then Momita, and then Prashant, Pooja, Rakesh Kumar, Roshan Raj, Rohit Singh, Saurabh Kumar, Saur Santosh Kumar, Simran, Suhani, Vikas, Aditi.
Yeah, Rajat, I'll ask one question on behalf of them. Uh, yeah, mostly I have seen the observation that the hiring here is in MTech, and we have BTech people from here also. So
Hmm.
how they can come? Like, what is the reality? Is hiring only MTech, or BTech guys are only also
No,
getting
no,
here?
no. BTech is also available. BTech is also hiring, but the thing is, it depends on the college to company. Like I was in DTU, right? Texas Instrument, AMD, like all the company are
Yeah,
allowing the BTech students, right? So
yeah,
it depends on the college to company. TNP have the power. If they want, they can allow the BTech students also. It is like that in your college itself. NIT Rourkela, Logic Food is coming. I guess Logic Food, Cadence and
yeah.
Scopus, they
It
are
comes
hiring
here.
also.
Yeah.
BTech, BTech is also hiring, but obviously some companies are prefer the MTech. It is not like that. If you have the skills, now you can. BTech is more than enough, right? If you want, because you are from NIT, why you will go for like masters, right? Just take your interest, right? Work in India for 1 or 2 years, then go for the masters from the US. That is much better as compared to the doing a BTech, MTech in like some from NIT, because you are already from NIT, right? So that is a thing.
Yeah. Yeah, so you heard, guys, BTech hiring is also happening, and colleges come to our college. As you mentioned, Logic Root, it also comes in our college. Cadence
Off
comes.
campus,
They
off campus you will also get, but obviously for the off campus, system LOD and UVM is compulsory for the front end. Skills are more, and even projects you will need more because there is more competition in the off campus.
Yeah, true, true. I guess Santosh has a question in chat, and he says that, Sir, I have learned Verilog as a beginner, but it's difficult to write code easy. I'm able to thought the logic perfect. So please tell me regard Verilog. Okay, basically he's telling he's able to figure out the logic, but how to translate in terms of Verilog, he's not able to figure out. Can you have any
You just have
advice
to
on
do
this?
the practice. You just have to do the practice again and again. That is the only thing. You have to use a software also. It is not like that you are writing on the pen and paper. You install the Vivado or Model Sim, whatever you have, or even EDA Playground is there. Practice more and more. Uh, and within 15 to 1 month, 15 days to 1 month, you will be expert. Write at least 100 codes. 100 codes. You can initially you can see the code and just execute it once. And whenever you become the after like even like after getting executing like 30 codes, you will be getting a confidence, right? Because this is a practice only.
Yeah. Yeah, so thanks for that, and I'll wrap up with a final question. What is okay? There is one more
Campus
question.
opportunities
What
are there.
are the
Yeah. There are a lot
yeah?
of
What are the
opportunities, but right now recession is going on, so obviously lesser opportunities are there. But it is not like that this is permanent. Cadence, Synopsys, Logic Fit Technologies, Intel, these are companies who are even like 50 plus companies who are for the off campus also. So, but the skills are needed. You can't only learn Verilog and digital and you can claim a job or even internship for the off campus. Campus you may get only Verilog and digital, but the off campus you will expect the more knowledge. That is the thing.
Yeah, very true. Skills are very valuable because they hire only quality guys. If you are a CEO of a company, you would hire good guys, right? So that's the thing. And there's one last question from my side. Like, what advice would you give for the current second years who are starting on this? What
Second year
things should they?
student should first of all download the application. There are 50 hour free courses are there. Both the free courses. If you are enjoying the classes, then after the like 6 months or whenever you are going confidence, then go for them some advanced courses, right? So from any coaching center you can do, but advanced things are compulsory. It is not like that you have gone through the only basics because everyone knows the basics, but company will expect a relatively a better guy, right? That is the thing. If you are
Yeah,
everyone is learning the very low basics, obviously everyone will able to answer. But obviously, how the company will distinguish? Suppose Intel is coming to your college, right? They just have to hire two candidates. Obviously, they will hire the better candidate who have done the more project and to have the more knowledge. If you are going through the same knowledge again and again, that is not sufficient. There are a lot of things, right? There are so many profiles, right? So just install the application VLSI for all. It is absolutely free of the cost. There is free test series there, free interview guidance material is there. Like lot of free content is there. And if you think then if you like the free content, then you should go for the paid courses or from other coaching center also you can do the things. But advanced things are obviously needed for the off campus. And if even if you want the stability in your job, you have to learn the advanced things. It is not like you are getting the job and you have to get the stability in your job also. So obviously you can't skip the advanced things.
yeah, very true. Being relevant and learning is constant. Just one question. They are telling that where can we practice very long? Please suggest
Okay,
some
I will
websites
share
also.
the playlist of the free Verilog class, or it is in the app also. So yeah, it is in the application also. I will share the link of free Verilog class also. They can watch those classes, fine. Yeah. Anything else?
Uh,
Anyone?
yeah, I guess that would
Good
be all. You
evening,
can
sir.
share. Uh,
Yeah, yeah.
okay, we have please.
Sir, project is necessary for getting an internship in VLSI job.
100% within at least three, four projects for the off campus and two projects for the on campus. Why a company will hire you without a project? You tell me. Without a project, no one will hire anyone, right? See, if you are learning only Verilog and digital, you will write that I have learned the Verilog and digital in the resume. But if you are learning like UART, I2C, AMBA, you can write two lines. I have implemented UART, I2C using system alone UVM. You can explain these things in your resume. Even it will help in the resume building also. Without the projects, resume is nothing, right? Resume is absolutely nothing if you are learning anything without the project, right? So projects are necessary.
Yeah, and for the
Okay, sir.
projects, yeah, please have your digital basics and Verilog basics clear. Practice Verilog, and then you would only know that what projects you can do. Just start with Verilog. Yeah.
Yeah, obviously.
So, any more questions from anyone? I guess there are no questions, and we can wrap up the session. So, thank you, Rajat, for everything, and thank you, Ankit, for the nice presentation there. Looking forward to more collaborations like
Sure.
this.
Okay, fine. Thank you, Manshu. Thank you so much.
Okay,
Thank you, everyone. Thank you, guys.
thank you everyone.
Thank,
Thank you everyone. Bye.
thank you. Bye.